all the speakers are talking innovation today, and it's great. And what I really like hearing the most is they're also talking about keeping the no out of innovation, whether it's regulatory or just, public-private partnerships to speed it up, to avoid those valleys of death and everything else. But one thing is for sure, more will be invented in the next 20 years. Now they're saying next 5 years than the history of all of mankind. And the reason being is the inventions of the chip, software, the advanced computing, big data, and of course the internet, which has created overnight instant collaboration on a worldwide basis. And so we're in an incredible acceleration period right now that dwarfs in all respects the previous revolutions. I mean, it was great. The Industrial Revolution, when I went to school, that's what we heard about and everything, the invention of the machine, which led to the invention of assembly lines and how quickly that changed everything, but nothing like the one we've been in over the last 20, 30 years, which is the digital revolution, where we've basically digitally re-architected virtually everything. And having lived through that and getting to be part of inventing instant messaging and cable modems and things like that and seeing the changes happen very, very quickly, the early side of that is no one believed any of that would happen. Nobody believed any of it would happen. And the next one, I believe, without question, and not the only guy in the room or the only guy in the world, because it's clearly a moon race right now, is nanotechnology. What we're seeing happen right now in the ability to create nanomachines, all types of enabling nano products. It's the fastest growing new technology in the world, bar none. And so on the picture you're seeing right there, that's a nano gear. That's invisible. It's in your cell phone. It used to be, it still is to a certain extent, a trigger device in atomic bombs, and it's been around about 15 years. So don't think nanotechnology just started yesterday. And just like the analog to digital revolution that disrupted everything overnight, I mean, literally in what seemed like minutes as we went from, brick to click, period, almost. Now we see going from micron scale to nanoscale, which is a billionth of a meter, so it's about, in terms of the thickness of a piece of paper, it's 100,000 times smaller than the thickness of paper. To really put it in this type of season, it's equal to a football 1 nanometer to the planet Earth. And people are manufacturing around the world today at incredible speeds, new types of products down at that nanoscale. And at that nanoscale, things move very fast. If you don't believe things are moving fast, I brought this along just in case. What's in this device right here, and I had the opportunity to run PCS and cellular at Motorola for a while, every single thing that was sold at Radio Shack in '91 is in this device. Every single thing. Now, how did that happen? A lot of it is moving it down to micron scale and then into nanoscale. Nano comes in a lot of different dimensions, so it's a very complex technology. Starting down at Rice early on, the Nobel Prize, carbon nanotubes, it's so beyond that now, and it's all around you. There's not a manufacturer in the room or a manufacturer that spoke that's not using nanotechnology in some kind of way. If I pull up and use my glasses right now, the reason they're anti-scratch is nano. This suit, the shirt, and everything else has nano weave and other things in it. So it's all around you and moving at an incredible pace. Just to give you an example, because this is child's play, this is just a way to explain quickly how you can build at that level. So this is a submolecular, near nanoscale, complete reproduction of the London Bridge using 1 grain of sand. And that is just easy to do. There's nothing to that, and that was done about 15 years ago. Now, the reason we're able to do that and the reason nano engineering is moving so fast right now is all your universities are moving into that as one of their, if they're not biggest program around the world. It's not just something happening in the United States. And with the use of electron microscopy, we're able to do incredible things now in nanoscale engineering. So I'm out of the state of Arkansas. We have our 50,000 square foot facility there, and right down the street from us, we have 2 100,000 square foot nano engineering institutes, and in that one there's $70 million worth of electron microscopy. So public-private partnerships play a huge role in that. And of course for us, we're not in Research Triangle, we're not in Silicon Valley, but we move very quickly because we have access to intellectual human capital due to things like that to build out true nano manufacturing facilities that look like this. This is us. That's just one of 3 of our facilities. So it's really happening, and I wanted to make sure everyone understood that. And when we look at the numbers, it's not just happening in the United States. We are truly in a global moon race because everything's at stake in terms of manufacturing. If we don't lead as a country in nanomanufacturing, we'll quickly be reduced in the next 20 to 30 years as a second world country because everything that's manufactured is manufactured incredibly better at nanoscale. Proof's in the pudding. In terms of enabling products right now, trillions and trillions of dollars of products are incorporating nanoscale technology. Every one of our agencies in the U.S. government, through the NNI that was passed some time ago, about $22 billion spent so far by our government in this space, and continuing to be spent at a tune of about $1.5 billion to $2 billion a year, and not in any way keeping up with other countries such as Russ Nano, who walks around the country today. I've got a card in my pocket from a guy named Dimitri out of Sand Hill Road. And they've got a $20 billion fund where they're trying to either buy our nanotechnology or get on our board and learn it very fast. And I'm told by the FBI that my website in Little Old Arkansas is the most hit firewall in the southern United States by the cyber warfare militia team out of China. So it must have some meaning. And by the way, they're investing pretty heavily in this, just like they took it to us in solar, they took it to us in batteries and so forth. That's 120 acres, that's real now. And that's not for R&D, that's for pure commercialization of nanoscale technology in China. So get used to it. It's coming very, very fast. The reason being, among other things, is we're able to go down, that little n in nano actually stands for nature because we're down at a scale, some people call it nature, some people call it the God scale, but the ability to build virtually anything very, very quickly, very inexpensively, that lasts longer, works better than things that come before it. And because of that, looking into nature, and we do it all the time in the way we manufacture things, tells us a whole lot. So from this butterfly, I learned how to do super hydrophobics. I learned how to create new color items that never ever lose their color, so they're totally color fast. This didn't just start yesterday. There was a guy named Leonardo da Vinci back in about 1500 that was looking at biomimicry, looking at bat wings and so forth, and drew these images, and really led to some aviation type studies that even when I was an Air Force pilot and so forth, we looked at these kind of things, but now it's going into the next generation of aircraft like this, creating adaptive wings that literally using nanoscale engineering and technology means you're not going to have turbulence on flights, and means if you're a fighter pilot, you're going to be able to do things you never dreamed of in terms of rolls and things like that. The future of a design is going to come from a lot of this biomimicry, because at nanoscale we can look at things like this guy right here. This chameleon has a luminescent skin, totally different cell structure, and we've seen this when we were kids, right? But we haven't studied it because we haven't put this under electron microscopy and so forth. And so what we learned from that cell structure is we can replicate that very easily in nanoscale, so that when we build cars of the future, like 3 years from now, if you don't like that color, using that same technique, that same type of technology, if you want to change it overnight, just put an electrode up to your car, and if you don't like that color, switch it to green. And that's coming so fast, you just can't believe it. In warfare, all technology is weaponized very quickly. Out at Caltech early on, they looked at the dog's nose, said it's one of the greatest receptors, and this one in particular, of smell. So if you want to smell the enemy 2 miles upwind and know what they ate last night and which enemy it is, or if it's even the enemy, then convert that to a, using nanoscale engineering chipset that allows you to do that. And it also allows you to sniff out bombs if you're in airports and things like that better than any device or any dog's ever going to be able to do. If you're wanting to go even a step further, and you wanted to perhaps just, crawl up this wall of glass right here, study the gecko, because studying the gecko feet under electron microscopy reveals millions, actually billions of hairs on every foot, and the way they're curved. And if you study it as a scientist, you quickly learn how to create, first of all, devices like this, robots that can go anywhere, crawl up anything, and then it even puts you in the movies, of course, so you get to be with Tom Cruise and crawl up buildings in Dubai and things like that. Now, those gloves are real. They're used by the U.S. Army, so don't think these things are not 10 years out. They're not even around the corner. They're now. In the area of medicine, quicker than any area, the cures that you always hear for this, that, and the other are going to come through molecular devices, biometric level devices, nanoscale devices. These guys, these nanobots right here, are going to be able to go in, get to your tumor. It's going to make things like the treatments of cancer today and chemotherapy look like bloodletting of the 1700s, and this is within the next 5 to 10 years. It's moving at that kind of speed. These are called quantum nanodots, and the real ones can't show you, but believe me, it's coming. So that's the kind of fun side. They asked me to do a little bit of that. I actually run a real company that makes millions and millions and millions of dollars, and we work on things that are very current and very important. So we work in the areas like energy. The world runs machines. Machines run on lubricants. So we've created a whole new macromolecular, macrostructured, macrocomposited, intercalated open architecture approach to creating new types of lubricants that take away all friction, all wear, and drops the coefficient of friction down to zero. So when you see these massive truck lines like J.B. Hunt, Walmart, others that go by you, they're using our lubricants, thousands and thousands of them around the country. In the oil and gas fields, we've switched out all the lubricants to companies like Cameron. That's a $12 billion company. Whether it's out at sea, subsea, 4,000 miles down, it needs to last, that lubricant, 25 years. And it needs to last with salt water at 4,000, 5,000 feet. So their blow-off preventers work. We do stuff like that. This is real evidence. These are their pictures. So, if you're fracking, and this makes it a lot safer, too, because at nanoscale, you can take out things like the bad chemicals, introduce things like what we do here. So for our lubes, we take out ZDDP, zinc phosphorus, reproduce it with canola oil. It's just pure green, works about 1,000 times better than the old stuff did, and it gives you these kind of results. So what you're looking at on the left is using the best lubricant they thought in the world they'd used for 20 years. You can see it's destroyed after 10,000 cycles. This company controls all the flow of oil and gas on a worldwide basis to tune of about 70% market share using these valves. Simultaneously, we put in 5% of our nano-engineered N-Glide, and you can see zero wear. The lines you see, it's still retail. And on the left side, it took no time because that was all the lube that was left. On ours, we had another 45, it took 45 minutes to degrease it. So I brought along somebody to tell you this is actually true.
The developments weren't done in our own laboratory, and I didn't see the results with my own eyes. I still wouldn't believe it today. This really is a technological breakthrough, and I'm just proud to be a part of it for Cameron representing us here today.
So this year we put it in racers, and so we went with Penske. They said win the Indy 500. We hadn't won it in 5-6 years, so car number 1, we won it, and we also came in second. So some real evidence there on that. And when you win, you get in the winner's circle, which is a lot of fun. You've heard of a company called Tesla out on the West Coast. They were having some real issues with wear because it's unlike any other car. It's the most advanced car, believe me, without any question, in the world. In a lot of respects, not just because it runs on batteries, but it runs at 18,000 RPM to 20,000 RPM to get to those ludicrous type with buttons and things like that they have. Well, it takes incredible new types of lubricants that decrease wear down to zero. So they called on us. We fixed that. We competed against every lubricant company in the world to win that. And since then, we do about 6 or 7 other things for that company. In trucks, I mentioned that. We changed everything from the lubricants, so we double the life. We increased the miles per gallon. That's a good thing. We increased the horsepower just by changing the lube out. And we do that on thousands and thousands of vehicles. So don't think Nano's not for real. And we do it at every point on that truck and for many others. We get into coatings. I'm going real fast here. Not a lot of time to do this, but we can make the most, think Iron Man. So cutting tools, which is at the core of all manufacturing, we make those cutting tools just by putting a cubic boron nitride nano coating on it. Very, very safe. The EPA has given us 2 awards in the last 2 years, along with winning the R&D 100 in Edison for this, but that makes those tools last 2 times as long. And given the fact that China now controls 85% of the carbide in the world, and for that much most of the materials in the world, it's both saving that, and it's also keeping us in that business in terms of a country as we get into cutting tools, and it gives you those kind of dramatic results. And it allows us to build these things continually in the United States, manufacturing in the United States, whether it's jet engines. We're cutting about 75% of all of them now today, or as we move into the next generation of machines which have tighter tolerances that need new types of cutting tools. So whether it's antimicrobial, antibacterial, those type of things that go into textiles, all the way down to the most fireproof, not fire retardant, but completely fireproof, whether it's for the firemen or for your daughter's pajamas. Nanotechnology takes you there. It really does work. It's incredibly safe to allow you to do that. So rust eats 3% of the U.S. GDP every year, 3%. We're talking about nearly $1 trillion. We've eradicated rust, corrosion, using very, very safe nano-engineered. These are wheels off trucks you'll see out on the road every day. So there's a lot of things changing, but I'm finishing now. Most importantly to us is our national security, and so we need to be continuing to lead in nanoscale and engineering, manufacturing technology as a country, because everything you manufacture at the end of the day can also be weaponized. We want the best weapons. You've seen these UAVs, you've seen them everywhere. They're getting smaller. You saw one a second ago. They're going to get incredibly small, and this is the future basically of all warfare. And it's coming at an incredible speed. This is all non-classified, so you can imagine there's people in the room that know what I'm talking about. And if you want to see a video on this, go to our website at nanomech.com. And I don't have time to show that, but thank you for the opportunity to talk about nanotechnology and the importance to the United States of playing in this field. Thank you.